Okay, pin 1, getting nothing. Pin 2, nothing. Pin 3, nothing. Ugh. Okay, here we go. And I hear it. What is going on? Hey guys, welcome back to the channel. Got a super cool calculator today that I honestly didn't think I would ever have something like this. This is a Soviet-made Искra-121. So spark is what Искра means. Spark 121. It was made in, I believe, the late 60s or early 70s. We're going to find out in a minute. But it's got a Nixie tube display. And I don't have very much information. It came to us at a very low cost, basically a gift. And the guy who gave it to us said it wasn't working, and he had tried to get it going. So I see there's no plug on it. Before we turn it on, my plan is to disassemble it a little bit, do a visual inspection to make sure there's no clear problems inside. And then if all looks okay, we'll turn it on using our dim bulb tester over here and probably use Optimus Prime, my Variac, to bring it up slowly. So hopefully we can get this guy working today. If you like this kind of content, give us a like, give us a subscribe, because we've got more of this coming and it really does help the channel. Let's get started. So the first thing we see here is that this has clearly had a very long life. All of these buttons are physically like worn off. You can see it here on the 1, on the 4, but all of them have a divot where people were hitting them. I don't know what's going on with the 5. It doesn't push down anymore, but that's something we can try to fix. Maybe it's a 5 off another machine. This, I believe, is the clear button. Maybe these are memory buttons, I'm not sure exactly. And then over here we have this dial. This starts with a V and starts all the way from 3 and goes to 13. And I don't know exactly what this is. This might be a memory. These are memory settings for the calculator. Искра-121, 220 volts, frequency 50 hertz, weighs 12.5 kilograms, which is like around 27 pounds. It's pretty beefy. Then we've got a serial number, and oh, here's the dates, 1977, which is actually a little bit later than I thought. We're missing 1, 2, 3, 4, 5, 6 screws, which tells me someone's been in here before. This looks like an access panel, and it looks like there's a PCB under it, but the screws are tiny. I'm going to leave this alone for now and just take out the screws we need to take this top case off. So I think that means a few screws, and then we're into it. We've done some research. A1 and A2 are in fact memory registers. I still don't know what the dial is. This was produced from 1972 to 1979. So this unit is sort of towards the end of the production run. A lot of dirt and grease inside here. So I'm gonna guess this was used in maybe a factory setting of some sort. We've got 1, 2, 3, 4, around 15 boards. Most of them, as you can see, have chips, so then I'm assuming these are all for the memory functionality. This beefy thing is the power supply. Look at the size of this transformer here. I think we should first find out if this power supply is functioning the way that it needs to be functioning. And if we can take this out, then we'll go ahead and pull that and maybe do some testing with just the power supply. You can't really see it on camera, but the power supply goes all the way into here. There's a big filter cap right down here. I actually thought that this was going to be the big filter cap. That was pretty naive. First order of business is we got some super janky power cords here that I'm going to try to deal with. I've got this 3-wire cable that's already got a nice plug on it that's grounded, even though there's no ground going into this device. So we're going to ignore this ground lead for now. I don't know what goes in here, but this would have been the side of the device. What is this for? What is this tray for here? I don't understand what the point of that is. I feel like whenever I start some of these projects, I spend a lot of time just getting the cables managed so that I know that's not part of the problem going in. You see, I already messed that up. So we can plug this in and check AC coming to here. But before we do that, I'm seeing a fuse right here that we should check. Okay guys, so it's a little cluttered on the workbench, but we've got the dim bulb tester here. After that, in line, we've got our current meter and our voltmeter. You can see the voltmeter is already reading 220 volts. This is what we're going to plug in the power supply to, and this is what we're going to meter power supply. So if there's a short in the power supply, this voltage will go to 0, and these bulbs will light up brightly. And now when I flip this switch, we should see something happening. It's going to give us some information. Okay, now there's no load on it, so not entirely surprising that we don't have any current. But let's see if we can get some meter readings. I'm going to come over here to DC. And I believe the 7th pin here is ground. Nothing on 1, nothing on 2, nothing on 3, nothing on 4. Dead as a doornail. Okay, let's turn this off. Let's see if we can figure this out. Okay guys, so what I did is I went through and I looked at all these caps. The date code on all of these caps is 1976. So at a minimum, we're dealing with 35-year-old caps, and they should probably be replaced. So I'm gonna have to go through and I'm gonna recap this. Next, I know that AC, we're getting 220 volts AC, actually 190 volts after. Wait a minute, that shouldn't be 190 because this stays at 220. But when I meter AC here, I'm getting 190 volts. Let's just try that really quick. So this is here and here. Now I'm getting an open, I'm getting, what is that? You see these crazy readings I'm getting? What's that all about? What is that? Okay guys, it's been a few days now, and I went back and looked at the footage, and you guys have probably been screaming at the screen because I made a couple of really huge rookie mistakes. So bear with me. Rookie mistake number 1, I don't think that I had the device turned on when I metered it that first time. I had power going to the device, but I think that this switch was in the off position, which would explain why I got 0 volts coming out of it. Rookie mistake number 2, and this is even worse, I was metering AC current in a way that would never give me any sort of reliable numbers. I was metering AC current across this switch, which means I was only metering one leg of the, it just doesn't, I don't know why I was doing that. Like that wouldn't even work for DC currents. I guess I got confused in the moment. I'm not sure what happened exactly, but don't meter like I just metered. Again, very, very rookie mistake. So where does that leave us? I went ahead and changed the switch out because I went in, I had a switch just like it in my kit from some other Soviet device, and this did have some burn marks on it, so I did replace that. So at least now we know that the switch is not a problem. Number 2 is, I got a new meter. This meter I've had for a long time, it's been with me on a lot of projects, and it's gotten to a point where it's just not reliable. It doesn't give me reliable continuity settings. It's not auto-ranging, so just finding something as simple as resistance is problematic. I bought this EEV blog Bryman meter, and I feel like I just went from level 1 to level 9. It is so awesome. They don't sponsor me in any way, but I'll leave a link below because I just think it's a great meter. I've gone through this power supply and changed all the capacitors, and some of them were really problematic. I'm going to show you that in just a second. The only capacitor that I didn't change was this huge honkin' filter capacitor, which I just left in place. I didn't want to mess with that. Next, I went through and reflowed every connection on this circuit board. The circuit board's not that big. It only took me a few minutes, but the solder was 35 years old. So why not? Why not change it all? Last, I found another pinout for a possible pinout for this connector. And judging by the number of connectors, I think it's a little bit more reliable pinout. I'm not sure. So we have 2 sets of possible pinouts with different voltages. We're going to go through. If this matches either one, then we know we're on the right track. So let's go through now. Let's turn this guy, let's test this guy again. Well, first I'm going to show you these caps. Then we're going to test this guy and see if we have some voltages, correct voltages, see what the story is, And if everything is good, we'll move on to testing the whole device. So thanks for hanging in there with me. Thanks for your faith in me that I can actually figure this out. And let's dive back in. Okay, guys, I wanted to show you this. Two of these caps, these two caps right here, were roughly within spec. They were about 30% off, which is terrible, but not crazy. These others didn't register as capacitors at all. The device couldn't figure out what they were. And this guy, let's see what it says. And this guy registers as a 0.3 ohm resistor, which is pretty close to dead short. So I'm pretty sure that this particular cap, 200 microfarads, 50 volts, is no good. Okay guys, we're all set up to meter this power supply again. So I've got dim bulb tester plugged into mains power. I've got our meter cluster here plugged into the dim bulb tester, and you can see it's reading 220 volts, which is great. I've got our power supply plugged into this. Power switch here is off, so it's not sending any current right now. And this, I've confirmed finally, is the on position for the power supply. So we're gonna go meter into DC voltage mode. I am going to clip this meter on here because the chassis on this is grounded. Turn the switch on, and here we go. Pin 1, getting 0 volts. Pin 2, 0 volts. Pin 3, 0 volts. Pin 4, 0 volts. Okay, maybe I have the switch turned around. Also getting nothing on the meter. No power whatsoever. Okay, that's super frustrating. Ugh. Okay guys, so this is kind of confusing. There's a marking on the board that's a minus that suggests that this rail right here is the ground. But when I hook this up, it is not continuous with the chassis of the device. There's no continuity there. However, the next rail that should be positive, because I have a capacitor up here that has a positive next to it, is continuous with the chassis of the device. Also, I have the second pinout I have says that ground should be the first pin. And when I check ground on the first pin here, it's continuous. So it looks like this big rail right here is our ground, despite, oh, here's a minus sign. Oh, that's not the same rail. I just don't understand why there's a plus. The plus side of this capacitor would be going to the ground plane. It doesn't make any sense to me. And why the minus is not also continuous with the chassis. Why don't we measure the DC voltage going across the main filter cap? Okay, the device is turned on. Oops. It's in resistance mode. Man, I really got to be more careful. Okay, we're in DC mode now. Okay, 48 volts across the main filter cap. That tells us that the switch is working. That tells us the transformer is working. That tells us that the bridge rectifier is in some way working. So what comes next is everything goes to this board here. Okay, well I found one problem. 3 of these leads have snapped off the board. I mean, I have to assume that they go roughly in the position that they are right now. Red, white, white. But without a schematic, it's impossible for me to tell. So I am gonna start by fixing that. I don't know when that happened. Maybe it just happened, I'm not sure. If it didn't just happen, then okay, that's our culprit. Okay, let's try it now. What do we have on these? Got nothing on the first one. Second one is basically 19 volts. Third one is also 19 volts. No voltage, no voltage. That has nothing. That has nothing. Okay, well we have some voltages. That's progress. Okay guys, so as you can see, I have been messing around with this quite a bit. The reason why this looks horrible here is because I cut out all of the beautiful sort of wire looms that were in here and started going through to see where all these wires are going and try to make sense of the circuit because I don't have any schematics. So this is not, you guys are gonna laugh, but this is even actually me drawing out the first part of this circuit, starting with the mains power coming in, there's a transformer, there's the bridge rectifier, first main transistor. Anyway, this is, if I can get this into a decent form where it looks okay on paper, I'll add it in a link below. It looked to me like the base and the emitter were shorted on this transistor and this transistor. So I actually went out and I found some new old stock. This one appears to actually be okay. So let me show you how I'm testing that. I put the meter over here in diode mode. Put the positive lead on the base. I'm going to put the negative lead on the emitter. 0.48. Base to collector. 0.48. And now what happens if we go backwards on these? Should be open line. Good. So I think these two transistors are functioning properly. So I'm going to put them back in. Okay guys, I've made a bit of progress in our search for documentation about this device. First of all, I've got a technical description of the calculator now. It doesn't have any of the schematics, unfortunately, but it does tell us what the voltages should be coming out of the power supply. But more importantly, what I like here is that it tells us what the current draw will be for each of these lines. And we can use Ohm's law, voltage equals current times resistance, to know what value resistors to use for the dummy load. And then we can use power equals voltage times current to know what wattage rating those resistors need to be. The ground plane is showing continuous with the positive lead of the capacitor. .5 ohms, dead short. But I was looking at it, and one of these wires is coming from the positive lead directly to the ground plane. Why is that? I don't understand why that is. Then combine that with the fact that we have a positive of this capacitor also on that ground plane. I don't know if that's the plane that's connected to the chassis. And there's just a lot of weird stuff going on here. The only thing I can think of is that this device is putting out negative voltages. And if it's putting out negative voltages, maybe that's normal to have that. I'm not sure. So I'm going to power it on and cross our fingers and hope this works. Power is on, here we go. Whoa, okay. Dimble tester came on to tell us that we have a short circuit. Watch that, let's do that again. Look at that, voltage drops to 0. This thing just saved us. But why do we have a short circuit now? We didn't have a short circuit before. Why is there a short circuit now? I pulled this bridge rectifier off and tested these diodes. They all test fine. I pulled off this transistor, tested it, it tests fine. And when it was off the chassis, there was no short. And then I saw the small piece of silicone, I think it's silicone, insulation. And this piece of silicon insulation has a break in it right here. I'm not sure if they always had this break in it or if this break happened because I've been sort of jostling it around, but this needs to be replaced. While I was in here, however, I found something else. There's only 3 types of transistors on this board. We have this, which is a KT805A, and we have 3 of these, 1, 2, 3. Then we have this metal casing capacitor. This is a KT602G, and I pulled it out of the board, and we're going to test this right now. So when I tried to test this with a multimeter, I couldn't get any readings across any of the legs. So I hooked it up to our component tester here, which I understand is not completely accurate all the time. But look what we get. It's reading it as a diode. Should be reading it as 2 diodes. Or a transistor is what it should be reading it as. Let's move the legs around. Okay, and here it's reading it as an unknown part. So something is not right with this transistor. So this needs to be replaced. Okay guys, so we're here at the Dry Bridge Market. The story is that some of the transistors I need are old Soviet transistors, and one of them is super rare. I've asked a bunch of different places, but there are some guys here who specialize in Soviet components, stuff that's not made anymore. And Gardik, I think, my guy here, I think he's found some for us. So we're gonna go look around, we're gonna find Gardik and see if we can get the transistors. Let's go. Okay, this is Gardik. Gardik is our expert in all things electronics. He knows everything about Soviet electronics. The guy is just wealth of knowledge, and he has found for us these super rare transistors, and this might just save the project. So thank you, Gardik. Thank you very much. Okay, let's see if any of this made a difference. Powering on. No short. That's great. No short. Black lead on chassis. And nothing. 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 And nothing. Okay, back to the drawing board. Okay guys, so I moved the power supply, I took it home with me for the holidays because I wanted to spend some time with it while I was at home and sort of turn this problem over in my head. Why can't we get the voltages we want? And you're not going to believe this. Check this out. So I'm going to turn the power supply on, ground to the chassis, and watch the meter now. Minus 28, plus 109, minus 109, and minus 19. That is 3 of the 4 voltages correct. I don't understand what's going on. I think what's happening is the voltage at my workshop something must be wrong with it. Now, something else. This box over here, I finally did some research. This is an electromagnetic interference filter, which is a couple of inductors, a couple of capacitors, and a resistor. And I wanted to rebuild this, but I can't find any specs on what inductors I need. I have the information about the capacitors and the resistor, but I don't know which inductors. I'm really new to working with inductors, so I didn't just want to take a guess. So I guess for now we're going to leave this out, unless that's a huge mistake you guys think, so please let me know below. Okay, and here's the reference point. This is the power strip on the workbench, and it's giving us almost exactly 225 volts. We're going to go back to the workshop that I've been working at and measure that and see what the story is. Okay guys, I'm back at the workshop now, and I've got the meter hooked up to the line that I'm using to power the device. As you can see, it's reading almost exactly 220 volts. Over here, it's also reading 220 volts. And this is going through the dim bulb tester into my meter cluster over to our Bryman meter. And let's just do one more thing. Let's check the frequency. Frequency is 50 hertz, which is just like it was at my house. So I don't think the electrical supply is the problem here. We're going to test this transistor again, the one we put in. It should be reading as an NPN transistor, and it's not, it's reading as a diode. I think this transistor is blown. I'm going to replace this, see what we can do. Nothing, 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 nothing. I don't know where to go from here. All I can think of is to take the time to make another schematic, to draw out the schematic in total from start to finish. Then hopefully in the process of doing that, I will learn enough about how it works that I can sort of troubleshoot this thing. But I definitely don't understand why this is a positive ground device, other than the fact that it's linked to the negative voltages somehow. I've tested all the components on this board, everything. I can't understand why it's not producing the right voltages. Okay guys, you know what I'm going to do? I'm going to take the meter cluster and the dim bulb tester out of line and plug it straight into wall power. I don't know why that would make a difference, but right now I'm running out of ideas. Okay, here we go. And I hear it. What is going on? Black probe on chassis, minus 28, 109, minus 109. Minus 19. Okay, it's working. Those aren't the exact voltages. The minus 19 is not correct. The minus 19 should be minus 12. But The rest are pretty close to that. Why is it that plugging it into this meter cluster and my dim bulb tester, which you can't see here, makes a difference? The voltage coming out, the voltage supply is still 220 volts. The frequency is still 50 hertz. I don't have an explanation. It doesn't make sense to me. But the important thing is that now we've got this thing working. We understand it's got to go straight into the wall for some reason. So yes, okay. Next order of business is to get this capacitor hooked up a little more professionally. Right now it's just kind of hanging out there. Clean up these wires a little bit, remount this solder board, and then I'm going to build 4 different loads that I can attach simultaneously so we have maximum load on the device, and then I'll check back in with you. Okay guys, so here's what I've got rigged up here. So these are 4 loads for the 4 different voltages with appropriate resistance and wattage. You see I've got these really beefy resistors over here, some more beefy ones over here. This is the ground going to the chassis, and I'm a little concerned this is kind of a thin wire, but we're just going to go with it. So everything's hooked up. So we're plugged into mains power. When I hit the switch, we're going to be putting load on all 4 lines at once. So I'm really hoping, I'm nervous about this. I don't know what's going to happen. I don't know if there's going to be smoke. I don't know, because we're not hooked up to the dim bulb tester, so there's no safety. Okay guys, here we go. I'm not getting anything here. Why am I not getting any voltages? Oh, because I'm not I'm not plugged in. Okay, turn that off. So this first line should read minus 12.6, minus 12.6. Here we go. Minus 13.04. Okay, that's pretty good. So the next one's going to be minus 28. Now let's go to the, should be 100. 102.8. That's great. Minus 102.6. Okay, that is a successful test, guys. Very successful test. I'm very happy about this. We finally have a power supply that is working. Now, all of that has been compressed into a few minutes on camera, but you guys have to understand that I spent days troubleshooting that power supply. First, there were no voltages. Then there was a short circuit. We replaced the power switch, power cable, all the capacitors. One of the transistors, twice we replaced it. I reflowed the whole board. I checked all the diodes, and there's like 15 diodes on that board. Checked all the resistors. I've checked essentially every single component. So we have 4 voltages. 2 of them are within spec. The other 2 are very close to being within spec. They are within 300 millivolts. I'm going to call that good and throw caution to the wind and just say that power supply is ready for action. But before we hook it up, before we test it on the mothership here, I want to go through here and see if there's anything else that needs attention before we introduce electricity. I see some capacitors here on the indicator circuit. That's what I'm calling the Nixie tube circuit. Oh yeah, we've got lots of capacitors here. 1, 2, 3. Oh no, they're pairs. Okay, bring you in a little closer to take a look at this. All of these guys right here on the outside, these are all transistors. And then behind them, they've got these pairs of capacitors. And the good news is that they appear to all be the same. So we're looking at a 0.05 microfarad, 10% capacitor, 1976. But I think we should probably change all these out. For those of you who are Nixie aficionados, we're looking at an IN14, 16 Nixie tubes plus a smaller one over here. These guys right here are good candidates for removal to see what the story is. So I think I'm going to pull them out. Okay guys, I don't like the way this is going. So there's the leg I was trying to take off. But you see that trace down in there that's twisted? I don't really understand how it got twisted, but I don't like the idea of breaking one of these traces, so I'm putting this thing right back where it was, and we're just going to take our chances with it. So I want to pull out some of these boards here and see what the story is. Okay, so this board came out really easy. It required zero effort to take out. But I can tell you right now that we're going to need to do some cleaning of these connectors. Look at that. We don't want to get any of that stuff down in there. So that's going to require some pretty heavy-duty cleaning. A lot of transistors. Here's some diodes. You can look way back in here, where my finger is. There's a couple of cylinder-looking things, and I'm thinking those might be capacitors. So I'm going to take a look at that. Yeah, so here we go. We've got two 10 microfarad, 25 volt capacitors, 1977. But look how beautiful this board is. Oh, here's another one down here. Same thing. Just gorgeous, huh? Look at this thing. It's got this lacquer over it. So these look totally unmolested, these boards. And since we're here, I'm going to use some deoxits. Okay. Oh, I see the washer that we dropped hanging out down there. That needs to be extracted. There it is. Whew. So the story with the capacitors here is that there are 3 electrolytics. The rest are, I guess, paper. I don't know exactly what they are. They've got an aluminum casing, but they're not electrolytics. We're going to leave those alone. Whew. I'll stop talking. We'll just test it. But here we go. The big moment, everyone. I don't hear the power supply going. Okay, turning off. Oh, I saw a flicker of light. I saw a flicker of light in there, guys. All right, let's try that again. Whoa! Whoa, there it is! There it is, it's alive! Okay, just zeros, not getting any numbers. Okay, well we have 1 0 over here. Brighter dots there. So there's the minus, just came on. So I think I just subtracted 2 numbers and that's why the minus came on. 6 minus 5. Wow, so a lot of work went into that power supply to get us to this point. I'm gonna wrap up this video. As you can see, it's already dark outside. This has been many, many days of work getting it to this point. The next stage is to go into some of the logic and see what's going on with these numbers, why they're not responding the way we should. Hopefully we can get to a point where this thing is fully functional. I'm super excited that we got to this point because that power supply was dead. And I don't know if me messing with it made it deader, but now it's up and running. Thanks so much for coming along on this journey with me. If you like the video, give it a like, give it a subscribe, and stay tuned for the next part of this because we're gonna dive right into it and hopefully bring this guy back from the dead. Thanks very much.